just mention the broad overview of the lecture. Don't want to spend a lot of time on motivations, but suffice it to say that embedding agents within some spatial context, geographic or otherwise, is quite key to the purposes of many models. Sometimes it's key for expressing the essential dynamics for problems. The fact that rabies requires one animal to bite another and therefore can't be transmitted at a long distance. It can be transmitted locally. Or locality of influence. Sandy Pentland's studies have shown the disproportionate influence people nearby you have within your social network when compared to other people in your social network who are physically removed from you. You may think that there are similar closeness of friendships, but those close to you influence your norms more strongly. So spatial proximity has a lot to do with transmission of norms, transmission of attitudes, of information in some cases, although less so these days, cues, and also transmission of pathogens. Representing spatial topology or spatial layout can also give us insight into certain phenomena. So spatial concentration, for example, of environmental chemicals within so environmental adverse chemicals, so contaminants within certain regions of space. Of prions, we saw that in sort of the deer movement model for chronic wasting disease, percolation movement, down rivers or what have you. And spatial reference modes, cases where models give rise, like that model we started with on our first day of class, I believe it was, which gave rise to those rings of infection spread. Spatial reference modes that complement the kind of temporal reference modes we're used to dealing with in system dynamics. System dynamics, we often think about reference modes over time, oscillations or exponentially divergent behavior. Or damping behavior that leads to something becoming more and more smaller and smaller type of phenomenon. Here we're dealing with spatial reference modes we may want to capture. Why is it with rabies we see it spreading out in a sort of ring, for example? Why is it we see oscillations, etc.? So, and finally, spatial embedding can permit GIS integration. I didn't have the opportunity to weave that into today's lecture, but maybe I'll make that a separate lecture just on how AnyLogic can be integrated with GIS. So given the GIS systems out there, how do you link that into your model? If you want to represent rivers and you want to represent highways and you want to represent streets so that you could reason about people's movement through these landscapes, how would you do that within AnyLogic? And it turns out AnyLogic has some tools to allow you to link in with some popular formats, etc. Okay.